Good morning, students. In the last class, we have discussed the hierarchical clustering algorithm, and we discussed that how hierarchical clustering algorithm is different from the k-means algorithm. And in the today's class, we are going to discuss the implementation of hierarchical clustering. Okay. So what we are doing, we are importing some of the libraries before implementing the code here. So we are implementing here NumPy as NP, and as we are going to draw the dendrogram, so we are using here draw the graphs, we are using here matplotlib, and the same way I want to draw the dendrogram here, so we are importing here dendrogram from the scipy, and we are importing another method which is link method. So we are using this function from the scipy dot cluster dot hierarchy to perform the hierarchical or agglomerative clustering. So I'm using the using this function, actually I'm implementing the hierarchical clustering. And same way, I'm using here mat blocks. I'm importing here make blocks from the sklearn. So it's a we can say it's a function from the sklearn dataset module to generate the isotropic Gaussian blocks for the clustering. So whenever I want to design the cluster and I want to generate the isotropic Gaussian blocks, I can use make blocks here. Okay. So just I'm creating example data set here itself, and I'm trying to I want to create a hierarchical clustering here. So I create a data set first, and then we'll perform the hierarchical clustering on the data set. So what I'm doing, I'm creating a simple data set with make blocks for clustering. So I'm using make blocks to create a data set for me. And with this data set, I generate 10 sample, which is consisting of two features, and the whole data set will be divided into three clusters. Fine. So this is my requirement when I'm creating a data set. Fine. Now I'm using here random seed equal random seed of 42 because I'm generating the random numbers here. So I'm using here random seed 42. So this 42 could be of anything. You can use anything at the place of 42. So it will make sure that every time the same random numbers will be generated. Clear? So now I'm using here x comma equal to make blocks of n samples equal to 10 center equal to 3 and cluster standard equal to 60. So what we'll understand with this? See here, we are using here to create the data set. I'm using here make blocks, and I'm taking here n sample equal to 10, which is specifying that 10 samples should be generated, which I mentioned here in the requirement. And I'm saying center equal to 3. It is specifying the data should be grouped into 3 clusters. And I'm using cluster standard deviation equal to 0.60. It means it specifies the standard deviation of the cluster, which controls how tightly or loosely the points are clustered around the center. So standard deviation I'm choosing, it could be maximum 0.60, and it is specifying that how tightly or how loosely my data points are clustered around the centers. Clear? And X is nothing but the generated samples, which is consisting of 2D array. So I'll execute this line of code. So it is going to generate a sample data for me, which is nothing but a 2D array where each row represents a sample and each column represents a feature. So I have two features, so every row is representing one sample data and every column is representing the features, and I have two features. And here I am using a dash. This dash is nothing but the true label for the cluster, which are not used here but can be useful for evaluating the cluster algorithm. So we are not using label actually here, but we can use here label. Okay, so this is representing the true label, and it can be useful whenever I am implementing any clustering algorithms. I hope it is clear to this line of code is clear to you. Now what I am doing, so I have prepared my data set using make blocks. Now I want to perform the hierarchical clustering. So as I told you that we have imported linkage from the scipy cluster.hierarchy library, and we have imported this. So linkage function from scipy cluster hierarchy we are importing to perform the hierarchical clustering, or we can say agglomerative clustering. Hmm. Fine. And we are using here a method which is called as var method, which minimize the variance of cluster being merged. So if I want to minimize the variance between two clusters which are going to merge, I am using one method. We'll call it as var method. So I'm applying on this my I'm applying a linkage I'm applying on a linkage function, and what I'm passing my data set comma the var method, and I'm storing the value into the z. So finally, I have implemented the hierarchical clustering, and the same I want to display on the screen. I want to display through the graph. So I want to create a dendrogram, and the same time I want to display the data points on the screen. So if I'm using this, so first of all, I want to display such kind of graphing, and then I want to display the dendrogram. For that, we have used this particular code. So we have used the code. I want to plot the data, a scatter plot. I want to plot here to display my data. So data is scattered on the x-axis and the y-axis. So I'm using here plot.scatter here, which is a function of matplot.pyplot, we can say, and it is used to create a scatter plot. So what is scatter plot? Scatter plot are a type of plot that display the individual data point based on their x coordinate and y coordinate. So if I want to display the data points on x coordinate and y coordinate, I can use scatter plot. Fine. Now I'm writing here x colon comma 0 comma x colon comma 1. I'm passing these two things here, and I'm keeping x as value equal to 50. So what is x here? X is nothing but it is a two-dimensional, we can say. It's a two-dimensional array of matrix where this is representing a two-dimensional array of matrix where each row represents a data points and each column represents the features of the data. Okay, so this is the representation for row values and the column value. And when I'm taking so x is representing my two-dimensional array. So this x is nothing but my two-dimensional array, which is representing each row as a data point and each column represents the features of that. So when I'm saying this pool, so what does it mean? So it will select all the rows of the first column of x, fine, which correspond to the x coordinate of the data points, and this will select all the rows of second columns which correspond to the y coordinate. So if I want to keep x feature on the first feature on the x coordinate and second feature on the y coordinate, so I'm writing this line of code here. So I hope it is clear to you, and just I want to give the title of my graph as example data. Features, x label is feature 1, y label is feature 2, and I want to show that. So this data will be represented in this form. So I hope it is clear that how it works. Fine. So this is the representation of my data. Now I want to draw a dendrogram for the same. So if I want to draw the dendrogram for the same, I have written this particular code and I am drawing the dendrogram. Just I use the function dendrogram here, and on the z data, and the other things are similar to the previous. Just I'm giving the label, x title is dendrogram, x label is sample index, and y label is distance, and I'm displaying the dendrogram on my screen on z. So this is my dendrogram. You can see this 0 1 3 1 and 3 is combined with 0, and 0 1 3 is finally combined with this. Okay, so 2 over 7 is combined, then 8 2 7 is also combined, and we combine the finally this particular data points, and finally we got a single cluster here. So this is nothing but my dendrogram representation, which we have already discussed in the previous class also. So I hope it is clear that how hierarchical clustering can be implemented. So whenever you want to implement hierarchical clustering, you need to import the dendrogram library, dendrogram from there, and dendrogram from the SciPy library, as well as the linkage function from the SciPy library, linkage function from the linkage function from the SciPy library to perform the hierarchy clustering. So these are the two important things which we have used, and we have created a sample data set using make blobs here, which is new thing we have learned through this session. So I hope it is clear to you. So with this, I'm closing the session. Thank you.